Good afternoon, you guys. This morning in class, I tried to explore 2 and 3 dimensions with you using dimensional analysis, and I'll go over that content in a little more detail right now. You should be practicing problems in your class packet as I'm going over these pages. So have your class packet out, have a calculator out, and let me know how you're doing. I will share my screen to my slide presentation. Hey, how's that microphone sound? Pretty good to me. So 2D and 3D. In class, I went over some of my impressions after having graded some of your work. You can review these. Otherwise, I would say you're doing great. I see a lot of stamina, a lot of perseverance. When you need help, get help. 3 before me, but I am more than willing to help you also. I talked about the marks I put on your papers as I'm grading. You'll get these papers back. It's just I only see you once a week. Remember, tomorrow morning your picture on your measurement lab is due. Also, for the video check on Monday, I am including material from video lesson 2, which is really accuracy and percent error, in addition to all of the kinds of dimensional analysis. These words are on the bottom of your concept map. You can pause and look at these here or check out your class packet. These are words you need to be able to use appropriately. All right, I was flailing my arms around in class trying to talk about square areas, or areas are always square. The relationship between a millimeter, a centimeter, a decimeter, and a meter, going on up to kilometers, going on down to nanometers. Remember, you need to know all the prefixes that are highlighted on a particular sheet in Schoology Chapter 2. I think there are about 8 or 10, maybe 12 prefixes that you need to know. All right. So I went over this in class. To be able to tell me how many square meters are in a squared kilometer, first I think one dimension. I know there are 1,000 meters in a kilometer. So then I square it. There would be 1,000 squared meters in a square kilometer. So the answer here is 1 times 10 to the 6. How many square millimeters are in a square decimeter? Well, first I go down to 1 dimensions in my head and get that straight. I know a decimeter is 1/10 of a meter, which means it's 10 centimeters. If there are 10 millimeters in every centimeter and 10 centimeters in a decimeter, there would be 100 millimeters in a decimeter. Now, if you square that, 100 squared is 1 times 10 to the 4th millimeters squared are in a decimeter squared. I'm trying to show you that to do the 2 dimensions, I think 1 dimension first. To answer how many squared centimeters are in a squared meter, first there are 100 centimeters in a meter. So there are 10,000 centimeters squared in a meter squared. By demonstrating how I think through it, I hope it helps you think through it. This visual, I can support more in class with you as I've got all these volumetrics that I can show you. But just know that a cubic meter is about the size of a washing machine. A cubic decimeter is about the size of a half a loaf of bread, or maybe my 2 fists put together. A cubic centimeter is the size of the tip of my finger, just the tip of my finger. You need to know the relationship. Look closely at this picture to see that each of these are 1,000 times smaller than the preceding image. A liter or a cubic decimeter is commonly used. We drink soda from it, we have volumetric flasks and graduated cylinders that measure out this quantity. You really need to appreciate that 1 cubic centimeter is 1 milliliter. That is a definition. So you tell me how many sig figs are in the number 1 centimeter or in the number 1 milliliter. And I hope you're comfortable with saying infinite. Now, we can scale up that equality and say that 1,000 cubic centimeters equals 1,000 milliliters equals 1 liter or 1 decimeter cubed. Get comfortable with this because you need to use this when you do dimensional analysis. So I did this in class with you. I'd like you to take a minute and try to answer these 3 answers. Pause the video so that you can get all these answers. Maybe jot them down on a piece of paper in front of you. Pausing. And I'll move this, I hope I can move it, so that you can see those answers there. All right. Here are more for you to think about. Cubic conversions. Remember, first I think in 1 dimension and then I cube it. I'd like you to jot down all of these. It's not in your class packet, just jot them on the corner or the back somewhere. After you've got all of those written down, I'm pausing. You stop this video. Here are the answers. Now I'd like to talk to you about reteaching dimensional analysis. I'm just going to talk to you about how I would solve this. I'll get you started, you can finish it, and check your work for thoroughness, sig figs, and units on every number. By the way, I only really check sig figs for accuracy at the end of the calculation. I don't grade sig figs in the middle of the problem, but you should be writing them down correctly just so that you can figure out how many sig figs are in the answer. But I only grade the sig figs at the end. All right, so I am going to stop sharing my slides and I'm going to start sharing my Elmo, a document camera. All right, so here you have the problems that are on what page? 1 minute. Reteaching dimensional analysis. It is on page 13. Page 13, and I've got a paper here that I can write on. I think that would be most convenient. All right. 2 and 3 dimensions. You've got to find the right conversion factors. So let me talk you through this. Number 1, you're given a blue liquid. You determine the mass to be 6.48 times 10 to the 4th milligrams and the volume to be 54.0 cubic centimeters. What's the density? In grams per cubic centimeter. So here I would write the mass over the volume. Here's density equals mass over volume. So I'm going to write the mass 6.48 times 10 to the 4th milligrams over 54.0 centimeters cubed. Now the problem is they want the answer in grams per centimeter cubed. So now I see the problem. I've got to convert milligrams to grams, and cubic centimeters are fine the way they are. So that means you need one conversion factor that's going to convert milligrams to grams. Once you remember what that equality is, You can put the correct numbers on the top and the bottom here, and then you're almost to your answer. I'll let you finish that and check your answer on Schoology. B, what is the density of a liquid expressed in kilograms per meter cubed? Kilograms per meter cubed. Well, I have to use the answer from up above. So after you finish that, you'll see that is 1.20 grams per centimeter cubed. That is the density from number 1. And I want to get it converted to kilograms per meter cubed. The situation is converting grams to kilograms and cubic centimeters to cubic meters. Here's where you have to do that, thinking about units in 2 and 3 dimensions. So first, you can choose which one to change. Since the grams to kilograms is the easiest, I want to get rid of the grams, so I put it on the bottom, and I want the kilograms on the top. Now you just have to find out, remember, what is the relationship between grams and kilograms? There's 1,000 grams in a kilogram. Or you can say 1 gram is 0.001 kilogram. Both those are appropriate equalities. So you fill that in, and then the next thing I want to do is convert cubic centimeters to cubic meters. Here you have the challenging situation. You want cubic centimeters on the top, and you want cubic meters on the bottom. So how many cubic centimeters are in a cubic meter? If I think of this as a meter, I know there are 100 centimeters in that dimension, 100 centimeters in this dimension, and 100 centimeters in this dimension. So there is 100 times 100 times 100. That's 10 to the 2 times 10 to the 2 times 10 to the 2. There is 1 times 10 to the 6 centimeters cubed in 1 meter cubed. I would not write the number 1,000,000. It's not wrong if you do, but after a while we have to be sensible with the awkwardness of numbers that are very large and very small. I won't give you a die-hard rule on when to use scientific notation, but this is a reasonably large number appropriate for writing in scientific notation. That also means you need to be able to type that into your calculator. If you're having trouble, that might be your problem. Sit with someone 3 before me, but then come and sit with me and make sure you can put that number in your calculator. Otherwise, it'll just frustrate you not getting the right answers. Number 3, the area of your desk is 2.53 times 10 to the 6 millimeters squared. That's an area. They would like it expressed in meters squared. So how are you going to get to meters squared? You've got to figure out how many squared millimeters are in 1 squared meter. There's a conversion you have to do. Now I'm going to pretend like this is a meter, and here is a square meter. If this is 1 meter, if this is 1 meter, how many millimeters are in that length? 1,000 millimeters. So that means there's 1,000 millimeters on this side too. So to square 1,000 would be 1 times 10 to the 6th. Millimeters squared are in 1 meter squared. You can finish that and give me the answer right here. So you're giving me these answers and checking them on Schoology. Now I love these problems, and I want you to think hard about it, because this is where I see mistakes. Show me your work thoroughly and I'll find your mistakes. Here, if this is the equality, every equality can make 2 conversion factors. Find the 2 correct conversion factors from this equality. Do it again from this equality and this equality. Easy mistakes to make, be aware. Check those on Schoology. I think there's another page of those. Yep. Here's the other page, excuse me. The back page of that handout is the same kind of questions. Circle all the correct equalities for the mathematical relationship between the units of meter and kilometers. Meter to kilometer. Not all of these are correct, but many of them are. Circle the ones that are correct. Down here, I want you to circle all the equalities that are correct between the units liter and milliliter. Good challenge for you. If you have any questions, let me know. Otherwise, I'm going to go on to the next page of the class packet. Page 15. Page 15 has some worthy dimensional analyses that I'll start with you again, and you'll finish them. Page 15, class packet. Page 15. Two snails have a race. One snail speeds along at a blistering 2.561 times 10 to the minus 3 meters per hour. The other moves at a rate of 6.70 times 10 to the negative 4th feet per minute. Who's moving faster? Well, you have to convert one of those numbers into the other units. So you can do this one of two ways, and you only have to do it one way. On the answer sheet, I've done it both ways. You can take 2.561 times 10 to the negative 3rd meters per hour and convert that, I don't know how many you need, into feet per minute. That would require you're converting hours to minutes and meters to feet. As I said, I don't know how many of these you need, conversion factors, but you have to think of what they are. The other way you could do this is start with 6.70 times 10 to the negative 4th feet per minute and convert it into meters per hour. Only have to do it one way, but I've got both written in the answer key. This is not a hard problem. This does not involve 2 or 3 dimensions at all. This one is just fun. This is just fun because they're all made up problems, and you have to find the equalities and set them up. This is an appropriate question for do you understand dimensional analysis? So how do we start this problem? One minute. This problem says, if you went to Suggs Island with $100, it's hard to know where to start. How many Ferks would you be able to bring back to your loved ones for the holidays? Can you see that you start with the number $100? That's like the unit, and I'll assume that $100 is counted. I'll assume it's a counted number and unit. Now, you want to convert dollars to something else. And you want to do that over and over again until you get only Ferks. So where is an equality in here that has something to do with dollars? Right here. 1 grotto is $9.15. So I've gotten rid of the dollars and I can go on. Now I want to get rid of grado and go to the next unit closer to Ferks. Can you see anything with grados in it? Here it says a prot can be purchased with 2.5 grados. 2.5 grados is 1 prot. Do you see how that gets rid of grados? And now, how do I get rid of prot? 6 nays cost 7 prots. 7 prots, 6 nays. I've gotten rid of prots and now I have nays. To buy a Ferk, one must have 2 nays. 2 nays is 1 Ferk. So now I have all of these numbers with the units crossed out, and I can calculate the number of Ferks. How are you doing? Finally, the last one, you could do 2 ways, and I have it shown for you 2 ways on my answer sheet. You can do it with dimensional analysis, because with dimensional analysis, I know density times volume equals mass. And then I go on and convert the mass from kilograms into pounds. But you can also solve this by knowing that density equals mass over volume. Solve it with an equation. This problem gives me density and it gives me volume. Now I need a side calculation. And I need to calculate the volume, which is the length times the width times the height. And I have to find those 3 numbers and calculate volume, which would be in cubic millimeters. All right? Then I have to convert that into cubic centimeters, because this density is in cubic centimeters. I can do all that on the side of my paper showing the work, and I call it a side calculation. Then I come back and I put that volume in cubic centimeters right here. Do you see the density is in cubic centimeters? You would have converted your volume into cubic centimeters. Do you see that you can solve for mass? Mass would equal density times volume. You've got the density and you've got the volume in cubic centimeters. This mass would be given to you in kilograms, because that's what the density is in. So now you just have to convert, another side calculation, convert kilograms into pounds, and you would have your answer. You can see that this is 1, 2, 3, 4 different problems that you'll finally get to the answer. On my answer sheet, I have this done in one long problem using dimensional analysis. But kids usually don't like doing density in dimensional analysis, and you don't have to. All right. This is a long one, but I hope my going through this helps. I want to go back and share my screen for my notes. We have done these 3 problems. We've done these problems. We've done the group work and dimensional analysis, and I know this is the hardest. If you can get this, you are doing great. If you don't, I understand. This is the hardest problem in the class packet. To summarize lesson 4, you need to be able to find the right conversion factors by transforming an equality into 2 conversion factors. You have to recognize which is the correct conversion factor to use. And you have to solve dimensional analyses problems in 2 and 3 dimensions. This is something you have to remember all year. 1 milliliter equals 1 cubic centimeter, the tip of my finger. And of course, you know there are 1,000 milliliters in a liter, so there are 1,000 cubic centimeters in 1 decimeter cubed. I hope this is getting better and better. You'll be doing dimensional analysis for intermediates tonight. It gets a little harder. Do your best and see if it starts to make sense. Tomorrow, I start a Zoom laboratory with you. So I'll see you at the beginning of the double period in class. I will first review and answer any questions that you have on dimensional analysis, and then I'll go into the lab. If you feel as if the large class is not appropriate to ask me your question, I will linger. And if you want to ask me a question later on, after the class is over or later on in the day, we can get together and Zoom and answer your questions. Just email me. So, best of luck to you. I know your efforts will reward you with understanding. Keep working and persevere. This is something students master the first 2 weeks of IB chemistry, but not without some blood, sweat, and maybe some tears. Thank you very much for your attention. I will be saying goodbye. I'll post this video lesson number 4. Goodbye.